Assalamualaikum and good day to the honorable panels and supervisors. My name is Junaida binti Sulaiman. This is my third year in Bachelor of Mechanical Engineering Technology Manufacturing. Today I want to present my BSM1. The title is Semi-Automatic Pneumatic Actuated Otak-Otak Pin Insertion Machine. My supervisors is Dr. Muhammad Farid bin Syari and Dr. Salwa Mahmud act as co-supervisor. Okay, this is the points that I am going to present today. Okay, now let us get started. Otak-otak is a popular demand traditional food that can be found in two types. The one that is wrapped by the banana leaf or nipah leaf, and the other one is the popiah otak-otak that is wrapped with spring roll skin. Studies were made on local enterprise that specialize in producing the otak-otak based in Johor. The intention is to find out what is the real issues in the otak-otak production process. This research aims to make a smooth otak-otak production process so that it will help in increasing the production of otak-otak. What problems have been found? It was found out that most of the production process was done manually or by using a traditional method. In the wrapping section, the bottleneck has occurred caused by the manual pinning process of the otak-otak. The manual pinning process is done because there is no special machine for the task. So what can we do to eliminate the problem? We can accelerate the pinning process by developing a machine that can help doing the task. This solution is believed will benefit the workers at the wrapping station in the production line. From the problem statement, the research aim has been set to design and develop a semi-automatic pin insertion system that could increase the production rate. To achieve the aim, the objective are as shown. First is to determine the pin insertion mechanism for otak-otak making machine. Second, to develop the automatic pin insertion mechanism. And third, to verify the pin insertion function mechanism. The significance of this research is recently there is no special machine for pinning the otak-otak or other foods that is wrapped by using a leaf. This issue has raised the interest to develop a pin insertion mechanism that is ergonomic, that will eliminate the hazard and increase comfort among workers. So when the production line is smooth, so the production output will be increased. So this will benefit the SMEs because the manufacturing time and cost will reduce and will lead to increase in their profit. I want to highlight two main components in literature review. The first one is the otak-otak production process and the second one is otak-otak making machine. So here is the whole process on producing the otak-otak, starting from cleaning the fish, filleting, fine grinding, mixing, wrapping, packaging, and lastly storage. As I said before, the problem was found at wrapping section. So now let us take a look at the process on the wrapping section. So what has happened here? The first operator will put the otak-otak paste on the first nipah leaf. Then the second operator will take it and cover it with the second piece of nipah leaf. Then pin on one end, rotate and pin on the other end. Then after that, the operator will arrange the otak-otak in the basket. First task done by the first operator. It is a repetitive task. The bottleneck occurred here. The issue is the unwrapped otak-otak fillet is exposed to the environment, which have risk to be contaminated. The other four tasks done by the second operator also a repetitive task that can cause fatigue. They tend to get punctured by the sharp bamboo skewers and experience finger pain. Now we are clear on the production process. Next, for the Otak-Otak making machine, the pneumatic system is selected to make a functional pin insertion machine. The pneumatic system is selected because it is widely used in the food processing industry. It is cleaner compared to hydraulic system. Besides, it is cheaper, easy to operate as well as to maintain. This is the list of similar research on innovating the otak-otak making process. Title number 4 has been chosen because the pin insertion system is good but need an upgrade to make it better. The picture shows the machine that has been constructed previously. I've gained experience using this machine. Through the experience, I found out that this machine has a very good pin insertion mechanism. But the way the operator needs to hold the otak-otak during pinning process is dangerous because the risk of being punctured by the high-speed pinning. The other one is the pneumatic foot pedal also needs to rearrange because my foot often bump into the machine leg while trying to step on it. From the review, the mechanism of otak-otak pin insertion must be designed. So this is the method that has been used. First, the design process and design concept is done using scamper method and morphological chart. Second, the detailed drawing is produced using SolidWorks software referring to the design concept. Third, the pneumatic system is designed using Festo Fluid Sim software. And finally, the steps to validate the pneumatic system is prepared. This is the flow of the research. The green color is the flow for PSM1 and the pink color is the flow for PSM2. This is the Gantt chart that indicate the date of planning, yellow color, and the actual activities, green color, consisting the needs for chapter 1 until chapter 5. The activities for PSM1 have been planning to be done in 15 weeks for the semester starting from 21st March until 3rd July this year. For the design process, camper method has been used. This is actually a game created by a person named Abel for children to develop their creativity using imagination. So this process must start from S, that is substitute, then followed by the other letters in the acronym. Referring to title number 4 on previous research just now, so what is the thing or process that can be substituted? The answer is the pinning task that is done manually. From scamper method, the proposed mechanism is a clamp that prevents the wrapper from being unfolded, bender that replaces the operator's task, a lifter to remove pin otak-otak from holder, the ejector to push out otak-otak to the basket, and the push button to replace foot pedal. The idea is at the initial stage, the holder must be able to hold the otak-otak, while the top part named the bender will hold the leaf from being unwrapped. When the cylinder moves down, it will bend both ends and ready to pin the leaf. Then after that, the pin otak-otak must be lifted from the holder and ejected by the springy parts directly to the basket. From the sketches, several design concepts have been developed. First design had an issue on the ejector where it will collided with the machine frame. The second design can function as required, but the whole design looks fragile. Most of the parts need to be custom made and will have an issue during assemble. The third design is the final design where it looks sturdier, more sturdy compared to the other. Let us look at the video on how the machine will function. This is how the otak-otak is placed on the machine. Bending, pinning and remove. The lifter then will lift out the otak-otak. Next is pneumatic system design. The system will use 2 cylinders, 4 solenoids, 4 limit switch and 2 push button. The sequence was arranged so that it follow the process as shown in the video before. Here we can only see the circuit flow when doing the test run. but the system will only valid when it is attached to the machine and the test run begun. The research is expected to successfully develop the Otak-Otak pin insertion machine that can function well with the pneumatic system. A safe and good functional machine will help to eliminating the risky task on pinning the Otak-Otak wrapper. It is believed that the production number will increase by reducing lead time and cycle time in the production process. For the conclusion, again, we notice that the growing demand of Otak-Otak causes its production to be increased. This research goal on designing and developing the semi-automatic pin insertion system will help in increasing the production rate. At this stage, the mechanism has been determined and the design has been produced. That's all from me. Thank you.